Have you ever wondered if there's life beyond Earth? What if there's a planet out there with the right conditions to support life, just waiting to be discovered? NASA's Pandora mission is about to take us one step closer to answering that question. By exploring the atmospheres of distant exoplanets, Pandora will give us the tools to understand these alien worlds like never before. Could one of these planets be the next Earth? Join me as we dive into Pandora's exciting mission and uncover what it could mean for the future of space exploration. The Pandora mission. Have you ever looked up at the stars and wondered if there are planets out there just like Earth? Imagine a mission dedicated to exploring these distant worlds and uncovering their secrets. Well, get ready, because NASA's Pandora mission is set to do just that and more. But what exactly is Pandora? Let's dive into it. The Pandora mission, launching in late 2025, is a groundbreaking project by NASA that will focus on studying exoplanets, those distant planets orbiting stars outside our solar system. Now here's the exciting part. Pandora isn't just about discovering new planets, it's about studying their atmospheres to see what they're made of and if they could support life. This is a huge leap in space exploration, as understanding alien atmospheres is a key step in the search for habitable worlds. Pandora will be equipped with state-of-the-art technology to observe these planets in ways we've never been able to before. For instance, it will continuously monitor exoplanets as they transit in front of their stars, allowing Pandora to analyze their atmospheric composition. This means that for the first time, we'll get to peer into the alien skies of distant planets, uncovering what makes them tick, and potentially identifying the ones that could harbor life. The Pandora mission is set to open doors to a whole new era in space exploration, where we can finally start answering one of humanity's most profound questions. Are we alone in the universe? Mission objectives. Now you might be wondering, what exactly will Pandora be doing out there in space? Well, Pandora isn't just a mission to look at distant stars, it's a mission with a mission. NASA's goal for Pandora is ambitious yet exciting: to study the atmospheres of at least 20 exoplanets, monitoring them for over a year. How does it plan to do that? By observing them multiple times, tracking their atmospheric changes as they orbit their host stars. The key to Pandora's success is its ability to observe these exoplanets during their transits, which is when they pass in front of their stars. This is a golden opportunity for Pandora to take continuous readings over a 24-hour period. By capturing light from the stars and analyzing how it interacts with the exoplanet's atmosphere, Pandora will be able to detect the chemical composition of these atmospheres, essentially reading the air on alien planets. What makes this mission even more fascinating is its ability to do all of this on a large scale. Pandora's goal is to observe at least 20 different exoplanets, making this one of the most detailed studies of alien worlds to date. By capturing data from multiple planets, scientists will not only gain a deeper understanding of individual atmospheres, but also compare them across a range of environments. Is it possible that some of these planets could sustain life? Pandora's findings will bring us one step closer to understanding whether we are alone in the universe. Scientific significance. You might be asking, why does Pandora matter so much? Well, the scientific significance of this mission goes far beyond just exploring distant planets. Pandora's work will give us the tools to answer some of the most pressing questions about exoplanets and their potential to support life. Imagine being able to peer into the very atmosphere of an alien world, uncovering its chemical makeup and finding out if it has the building blocks necessary for life. That's what Pandora is aiming to achieve, and it could change everything we know about life beyond Earth. One of the key challenges when studying exoplanets is distinguishing between signals from the star and those from the planet itself. Pandora will tackle this head-on. By focusing on transiting exoplanets, it will monitor them as they pass in front of their stars, allowing scientists to study the planet's atmosphere without interference from the star's light. This ability to separate the two signals is crucial for getting accurate, detailed data about what these planets are really like. This precise data could eventually help scientists determine which exoplanets might be capable of supporting life, based on factors like the presence of water, oxygen, or other life-essential elements in their atmospheres. What Pandora will also help us understand is the diversity of exoplanetary atmospheres. By observing a range of different exoplanets, each with unique characteristics, scientists will be able to compare and contrast these atmospheres. Are they thick with clouds like Venus, or thin and airy like Mars? Or maybe, just maybe, some of them share similarities with Earth's atmosphere. Pandora's findings will provide crucial insights into the many different environments that exist on exoplanets, and, just as importantly, which ones might be candidates for life. Technical details. Now let's get into the fascinating tech that makes Pandora such a powerful tool for space exploration. The heart of Pandora is its 45-centimeter Cassegrain telescope, a cutting-edge piece of technology that will enable it to study exoplanets with incredible precision. This telescope isn't just any ordinary instrument. It's designed to capture both visible light and near-infrared wavelengths. What does that mean? Essentially, Pandora will be able to see exoplanets in ways that other telescopes can't, allowing it to detect the faintest signals coming from the planet's atmospheres. But the telescope itself is just one piece of the puzzle. Pandora is also equipped with spectrometers, which will break down the light it collects into detailed spectra. This will allow scientists to analyze the specific chemical composition of an exoplanet's atmosphere. By studying these spectra, Pandora can identify gases like carbon dioxide, methane, and water vapor, each of which could be crucial in determining whether a planet is habitable. It's like having a cosmic detective examining the air of distant worlds. One of the key features that sets Pandora apart from previous missions is its dual-use capabilities. Not only can it take stunning images of exoplanets, but it can also perform spectroscopic observations at the same time. This means that Pandora won't just give us a pretty picture of these distant worlds, it will provide real, actionable data that can tell us what's going on in their atmospheres. With its ability to do both tasks simultaneously, Pandora is set to deliver a comprehensive understanding of exoplanets in a way we've never seen before. Mission operations. Now that we've discussed Pandora's incredible technology, let's take a closer look at how this mission will operate in space. You might be wondering, how does Pandora manage to capture such detailed data from the vastness of space? Well, the answer lies in its carefully planned orbit and advanced spacecraft systems. Pandora will be placed in a sun-synchronous low-Earth orbit, a strategic position that allows it to have consistent and predictable observation conditions. What makes this so important? In this orbit, Pandora will always be in the right position to observe exoplanets as they transit in front of their stars, ensuring that the data it collects is reliable and continuous. This consistency is key to understanding the dynamics of the planet's atmospheres over time. The data will be collected in a way that gives scientists a complete and accurate picture of these distant worlds. Managing the spacecraft's operations is the job of Pandora's highly sophisticated spacecraft bus. This bus is like the brain of the satellite, coordinating everything from navigation to data acquisition. The spacecraft's onboard systems are responsible for making sure Pandora stays on course, collects the necessary data, and communicates with Earth. It's designed to handle the complex tasks of space exploration while ensuring smooth, uninterrupted operations throughout the mission's duration. These systems also allow Pandora to autonomously adjust its position as needed, ensuring it never misses an opportunity to study a passing exoplanet. It's a perfect combination of cutting-edge technology and meticulous planning, all working together to deliver unparalleled insights into distant worlds. Future implications. So what comes next? After Pandora has completed its mission, the impact of its discoveries will extend far beyond just the scientific community. The data Pandora collects will lay the foundation for the future of space exploration, potentially influencing missions that aim to find Earth-like exoplanets capable of supporting life. But the implications don't stop there. Pandora will also enhance our understanding of what makes a planet habitable, which is essential for the long-term goal of interplanetary colonization. Pandora's success will directly contribute to the growing field of exoplanet research, expanding our knowledge of the universe and helping to answer the age-old question, are we alone? Its observations of alien atmospheres could reveal signs of life in places we never thought to look before. In fact, Pandora could provide the first hints of alien biosignatures, gases in a planet's atmosphere that could indicate the presence of life. This would be a groundbreaking achievement, opening the door for even more ambitious missions in the future. The Pandora mission also acts as a stepping stone for more advanced space telescopes and missions. By refining our techniques for observing and characterizing exoplanets, Pandora will make it possible for future missions to go even further in their exploration. These advancements might one day lead to the discovery of exoplanets that not only resemble Earth but also possess the conditions necessary for life to thrive. Pandora's contribution to space science will echo for years, shaping the way we approach the search for life beyond Earth and our understanding of the cosmos. And there you have it. NASA's Pandora mission is set to unlock the secrets of distant exoplanets, bringing us closer than ever to understanding the potential for life beyond Earth. What do you think? Could Pandora's discoveries change the way we look at the universe? Drop your thoughts in the comments below. If you enjoyed this deep dive into space exploration, don't forget to like, share, and subscribe to Space Facts for more mind-blowing content about the cosmos. Stay curious and keep exploring with us, because the universe is full of mysteries just waiting to be uncovered. Have you ever wondered how the universe will end? What will happen to Earth, to the stars, and to everything we know? Imagine watching time unfold at a breathtaking speed, from the rise of civilizations to the ultimate fate of everything. What does the future hold for us and for the universe itself? Time-lapse of the future. A journey to the end of time takes us on an extraordinary ride, offering a glimpse into a future that is both awe-inspiring and a little unsettling. Are you ready to explore the mysteries of time? Let's dive in and find out together. Journey to the end of time. Have you ever wondered what the future holds? Not just the near future, but the distant, unfathomable future of the entire universe? Imagine if we could compress billions of years into just a few minutes. That's exactly what time-lapse of the future, a journey to the end of time, does. This isn't just a time-lapse of Earth or our solar system, it's a cosmic odyssey that takes us from the present day all the way to the ultimate fate of the universe. Created by John Boswell, this 29-minute film offers a breathtaking exploration of what's to come as time unfolds, both for our planet and for the universe at large. As the future speeds by in a few short minutes, we're given a front-row seat to the wonders and the mysteries that await us. From human achievements to the most extreme cosmic events, this film pushes the boundaries of what we think we know about time and existence. You'll experience the rise and fall of civilizations, the birth and death of stars, and the transformation of entire planets, all happening at once in a stunning visual representation. The film opens in the year 2019, introducing us to the Anthropocene, a new geological age defined by human impact on the planet. But this is just the beginning. What happens next is both awe-inspiring and sobering. The film takes us on an incredible journey, showing us how the world changes faster than we can ever imagine. And ultimately, how everything, even the universe itself, will meet its end. It's a thought-provoking ride that leaves you contemplating your place in the vast, ever-moving river of time. And the best part? It's not just a journey of the mind, it's a visual experience you won't forget. The Anthropocene and human milestones. The future isn't just about what happens to the universe, it's also about what we, as humanity, will achieve along the way. Time-lapse of the future begins by placing us at the dawn of the Anthropocene era. The world we know today is shaped by human progress, and while it's easy to focus on the challenges we face, this film reminds us of our potential. The Anthropocene marks the point in time when human activity began having a profound and lasting effect on the Earth, everything from the construction of cities to the rise of new technologies. As we move through the future, we witness the incredible milestones humanity will achieve. Imagine this. Humanity has finally set foot on Mars, opening the door for interplanetary travel and establishing our presence on another world. This isn't science fiction anymore, it's a possibility within reach, and that's just the beginning. The film zooms in on our future space explorations, including the possibility of human settlements beyond Earth. What will it be like to live on Mars? How will we adapt to the harsh realities of space, and what role will technology play in our survival? But the journey doesn't stop there. It's not just about getting to Mars. The future is filled with even more ambitious plans, from harnessing the power of renewable energy on a global scale, to potentially even altering Earth's environment to make it more hospitable for future generations. With every milestone, humanity takes a step closer to becoming a true spacefaring species. As the years pass in this fast-forwarded timeline, we see Earth transform in ways we can only dream of today. It's a future that inspires us to think bigger and bolder about the path ahead. Cosmic events and Earth's transformation. As the future unfolds, Earth undergoes monumental changes, but it's not just human progress that takes center stage. It's the unpredictable and sometimes violent forces of nature that shape the planet. Imagine watching as Earth evolves over millions of years, transforming before our very eyes. In this section of the time-lapse, The film highlights the dramatic events that will change our world forever, many of which seem almost too extraordinary to believe. First, we witness the return of the famous comet Hale-Bopp in 3357. Its presence in our sky would be nothing short of awe-inspiring, a cosmic reminder of the vastness of space. But that's just the beginning. Over time, Earth's environment begins to shift in radical ways. Sea levels rise, submerging vast portions of the planet's coastlines, and the Earth's surface starts to look vastly different from anything we recognize today. Imagine cities swallowed by the rising tides, leaving behind only the memory of a once thriving civilization. But there's more. In the year 5360, an asteroid impacts Earth, triggering a global catastrophe. It's a stark reminder that no matter how advanced we become, the forces of nature remain unpredictable and powerful. As the film continues to move forward, the Sahara Desert, once an arid wasteland, transforms into a lush, tropical landscape, showing how climate and geography can change in the blink of an eye. As the years press on, humanity might not be the only intelligent species we encounter. In 4226, the Voyager 1 spacecraft passes by the star Gliese 445, which is expected to be one of the nearest stars to Earth. Could there be alien life forms beyond our understanding? This section of the time-lapse reminds us of the fleeting, fragile nature of our world, and how everything, every creature, every city could be erased by forces much greater than ourselves. The death of the sun and the end of life. The inevitable truth is that no matter how much we achieve as a species, no matter how far we venture into space, the end of life as we know it is written in the stars. Fast forward to over 2.9 billion years in the future, and the Earth we know is no longer recognizable. The sun, which has sustained life for eons, begins its final transformation. Its increasing luminosity marks the death of all plant life, a harbinger of the slow, relentless extinction of everything dependent on the sun's energy. The oceans, once teeming with life, slowly evaporate, and Earth's atmosphere becomes increasingly hostile. The temperature rises to unbearable levels, making it impossible for life to survive. As the sun continues to expand into a red giant, it engulfs the Earth, turning our once vibrant planet into a lifeless, scorched rock. It's a poignant moment in the time-lapse, one that forces us to reflect on our place in the universe. Yet as heartbreaking as this destruction seems, it is merely the beginning of a much grander cosmic evolution. As Earth is consumed by the sun's final stages, our star becomes a white dwarf, its once blazing heat reduced to a faint cold glow. It's the ultimate reminder of the impermanence of everything, even the stars that have guided us through the darkest nights. This segment in the time-lapse doesn't just show us the death of a planet, it challenges us to think about our own legacy in the grand scheme of the universe. What will remain when humanity is gone? What mark will we leave, if any, on the universe as time marches relentlessly forward? The degenerate era and black hole dominance. As the universe continues its journey through time, it enters a period of profound transformation. Welcome to the degenerate era, a future where the stars, once burning bright with energy, have exhausted their fuel and faded into the cold darkness of space. It's a universe populated by the remnants of stars, white dwarfs, neutron stars, and the towering, mysterious black holes that dominate the cosmos. These dead remnants continue to drift through the void, their existence marked by the slow ticking of time, a stark contrast to the vibrant explosions and glowing nebulae we see today. In this era, gravity becomes the universe's most powerful force. With most of the stars having burned out, the universe grows darker, quieter, and colder. The once glorious spiral galaxies we recognize today are no longer filled with the radiant light of stars. Instead, they're populated by these invisible giants, black holes, absorbing all matter that comes near, growing ever larger with each passing century. Entire star systems are swallowed up, never to be seen again, as the universe slowly empties. This era is a chilling reminder of the universe's eventual entropy. The once luminous galaxies and nebulae that filled the night sky are replaced by the crushing silence of space, where the only sign of life is the slow, inevitable death of the stars. It's an era where time seems to stand still, and life, as we know it, seems like a fleeting memory in the vast, unchanging expanse of space. The degenerate era asks us to confront a harsh reality. In the grand scheme of things, our existence is but a brief moment, a tiny spark in the dark void of eternity. The black hole era and proton decay. As the degenerate era fades, we enter the black hole era, a time where the universe is defined by the influence of its most enigmatic and powerful objects, black holes. These cosmic giants, which are already a dominant force in the universe, begin to completely shape the destiny of all matter. Over time, the black holes grow even larger, their immense gravity warping space-time itself, pulling everything in their path into their all-consuming depths. But this isn't the end. Even these mighty black holes eventually face their own end. In a mind-boggling twist, the universe's matter begins to disintegrate. Protons, the building blocks of atoms, start to decay, turning the universe into an even more barren place. It's almost as though everything that once defined the universe, the stars, the galaxies, the very atoms, slowly unravels at the seams. The film imagines a universe where matter no longer behaves as it once did, where even the most basic building blocks are no longer stable. This process of proton decay leads to the disintegration of everything, as atoms break apart and the universe becomes a giant sea of radiation. In the black hole era, the universe is no longer the lively, dynamic place we know. Instead, it's a cold, lonely expanse, dominated by the power of black holes and the gradual decay of all matter. As stars and galaxies fade away and even the basic structure of atoms dissolves, time itself becomes meaningless. What remains? Just a vast emptiness where the only thing left is the lingering presence of black holes, reminders of the cosmic events that once filled the universe with light and energy. The end of the universe and the arrow of time. And so we reach the end of the universe, a final chapter that is as inevitable as it is awe-inspiring. The universe, once filled with stars, galaxies, and the potential for life, slowly fades into an unimaginable void. The last black hole, having consumed everything it could, begins to evaporate, a process known as Hawking radiation. This marks the final moments of the universe's existence as we understand it. The fabric of reality itself begins to unravel, and all that's left is the ultimate fate of everything, a dark, cold, lifeless void. But even in this end, there is a sense of profound beauty and mystery. As the universe reaches absolute zero, time itself ceases to have meaning. The film takes us on a journey through this cold, silent expanse, asking us to reflect on what it means for time to end. It's a haunting thought, yet an essential one. The arrow of time, which once moved in a clear direction from past to present to future, reaches its final destination. The film concludes with a powerful meditation on time itself. Brian Cox's narration reflects on the fleeting nature of existence, urging us to appreciate the present moment. The universe may be dying, but our consciousness, our awareness of time, is alive. In these final moments, we are reminded that even in the face of absolute destruction, there is value in our brief shining moment of existence. This ending is as much a philosophical statement as it is a cosmic one. It forces us to confront the ultimate question: what will we leave behind when time itself expires? In a universe where everything eventually fades away, the question of meaning becomes all the more pressing. The universe may end, but our understanding of it, and our connection to it, remains as the final spark of life in the vast, endless dark. And there you have it, an incredible journey through the future of the universe. From the rise of humanity to the unimaginable end of time, we've explored the mysteries of space like never before. What did you think? How do you imagine the future unfolding? Drop your thoughts in the comments below. We'd love to hear from you. If you enjoyed this mind-blowing ride through time, don't forget to like, share, and subscribe to Space Facts for more incredible content about the wonders of the cosmos. Until next time, keep looking up. There's so much more to discover. Every atom in your body was once part of a star that lived and died long ago. That's not poetry, it's science. The stars above aren't just beautiful, they're the reason we exist. We are literally made of star stuff. Ancient civilizations worshipped them. Today, we know stars are born, they burn, and they die in explosions so powerful they reshape galaxies. So when you look up tonight, ask yourself, what are you really seeing? A light show, or the history of everything? Let's uncover the life and death of the stars and why their story is also ours. The birth of a star. Stars are born in the cold, dark expanses of space within massive clouds of gas and dust known as nebulae. Imagine these nebulae as vast cosmic nurseries where the ingredients for new stars are scattered across the universe. These clouds contain the raw materials, hydrogen, helium, and dust particles, that, when compressed under the immense force of gravity, can give birth to something incredible. Gravity is the star's first catalyst. It slowly pulls the gas and dust together, causing the particles to collide and condense, making the cloud denser and hotter. This process takes thousands to millions of years, depending on the size of the nebula. As the gas and dust compress, a new hot and dense core forms at the center called a protostar, but it's not quite a star yet. The protostar is still in the process of gathering mass and energy. The temperature and pressure inside this core continue to rise, and once they hit around 15 million degrees Celsius, something incredible happens. Nuclear fusion ignites. This is the moment when a star is truly born. Hydrogen atoms in the protostar's core start to fuse into helium, releasing vast amounts of energy. This fusion creates light and heat, causing the star to shine brightly. And just like that, a new star is lighting up the cosmos. The process continues, and as the star stabilizes, it enters the main sequence phase, which can last for billions of years. Stars may begin from the most ordinary of elements, but through the forces of gravity, pressure, and time, they evolve into shining beacons in the night sky, marking the birth of something far greater than just light. It's the beginning of a stellar life cycle that will span millions, sometimes billions of years. Main sequence. After a star is born and nuclear fusion takes hold, it enters what we call the main sequence phase. This is the star's stable period, where it spends the majority of its life. Think of it as the star's middle-aged phase, where everything is calm, stable, and most importantly, shining. The star is constantly fusing hydrogen atoms into helium in its core, a process that releases an incredible amount of energy. This energy is what powers the star and gives it its brilliant light. For a star like our Sun, the main sequence lasts for about 10 billion years. That's right, a star is in this phase for a very long time. During this phase, the star has reached a perfect balance. On one side, the energy produced by nuclear fusion creates outward pressure, which tries to expand the star. On the other hand, gravity pulls inward, trying to collapse the star. These two forces, gravity and fusion, counterbalance each other perfectly, keeping the star stable and glowing. For most stars, this is the longest period of their lives. They shine steadily, providing light and heat to their surrounding planets, and if they're lucky enough, they might even give rise to planets with life, like Earth. The main sequence is an incredibly important phase in the life of a star. It's during this time that stars reach their full luminosity, and for us on Earth, it's what allows the stars in the night sky to shine brightly. But just like every good thing, the main sequence phase must eventually end. But before we dive into what happens when the star runs out of fuel, let's just take a moment to appreciate this balance that makes stars like our Sun such essential players in the cosmic drama. This phase represents the peak of a star's vitality, and without it, the rest of the stellar journey wouldn't even be possible. Red giant phase. As a star like our Sun enters the later stages of its life, its hydrogen fuel in the core begins to run low. But don't think that means the end is near. This is just the beginning of one of the most dramatic changes a star will undergo. When the hydrogen runs out, the core starts to contract under gravity's pressure, and in response, the outer layers of the star begin to expand, cool, and take on a reddish hue. Welcome to the red giant phase, where the star grows into a colossal, glowing sphere. At this point, the star's core is much hotter than before, which allows the fusion of heavier elements like helium. As helium atoms fuse together, they form carbon and oxygen, and the fusion process generates even more energy. This energy causes the outer layers of the star to expand massively. In fact, a red giant can grow to be hundreds of times the size it was during its main sequence phase. If our Sun were to go through this stage, it would expand so much that it could engulf Mercury, Venus, and even Earth. Imagine our planet, once teeming with life, now being swallowed by a massive red-hot ball of gas. But even as the star swells in size, things are beginning to change beneath the surface. The increased temperature causes the outer layers to become unstable, leading to massive stellar winds that blow away the star's outer material. In some cases, these winds can carry away up to a third of the star's mass. As the star grows, it starts to shed its outer envelope, leaving behind a dense core. This core will eventually become what's known as a white dwarf, the next phase in the star's journey. While this red giant phase might seem chaotic, it's actually one of the most fascinating stages in a star's life. The transformation from a stable, burning furnace into a massive, unstable behemoth is an awe-inspiring sight, and it's during this time that some stars make their most significant contributions to the universe, creating the heavier elements needed for future star systems and planets. Supernova explosion. For stars that are much more massive than our Sun, the red giant phase is just the beginning of a fiery and explosive end. These stars, once they have exhausted their core hydrogen, undergo a more dramatic and intense series of events that lead to the birth of one of the most magnificent phenomena in the universe, the supernova. But how does this happen? It all starts when the core of a massive star starts fusing heavier elements like carbon, neon and oxygen into even heavier elements like iron. However, when the core finally forms iron, something changes. Unlike lighter elements, iron cannot undergo fusion to release energy. This creates a major problem for the star. Without the energy from fusion to counteract gravity, the core begins to collapse. The pressure from this collapse causes the outer layers of the star to implode inward at incredible speeds. As the outer layers crash into the dense core, they are thrown outward in a cataclysmic explosion. This is a supernova, a violent, explosive event that releases more energy in a single burst than our sun will release throughout its entire lifetime. The explosion is so powerful that it can briefly outshine an entire galaxy. During this brief period, the supernova becomes the brightest object in the sky, visible across vast distances. These explosions scatter the star's outer layers into space, enriching the interstellar medium with heavy elements like gold, uranium, and iron. Elements that are crucial for the formation of planets, life, and everything we see around us. Supernovae are essentially the universe's recycling process, creating new building blocks for future stars and planetary systems. But not every star dies the same way. While smaller stars will collapse into white dwarfs, the most massive ones undergo an even more fascinating fate: a neutron star, or, if the mass is great enough, a black hole. But before we delve into these stellar remnants, let's pause and appreciate the sheer cosmic power of a supernova. It's a spectacular end to a star's life and a beautiful beginning for the next generation of stars and galaxies. Stellar remnants. When a massive star explodes in a supernova, it doesn't just disappear into nothingness. What's left behind is a dense, compact remnant that is often more fascinating than the explosion itself. The fate of this remnant depends entirely on the mass of the star's core. There are two possible outcomes for the surviving core: a neutron star, or, if the core is heavy enough, a black hole. Neutron star. For stars with a core mass between roughly 1.4 and 3 times that of the Sun, the core doesn't collapse into a black hole. Instead, it becomes a neutron star, a celestial body so dense that its atoms essentially collapse into neutrons. A neutron star is incredibly small, with a radius of only about 10 kilometers, yet it packs more mass than our Sun. This density means that the star's gravitational field is extreme, and neutron stars are known to emit intense magnetic fields and fast-spinning beams of radiation, which we detect as pulsars. These pulsars can spin up to several hundred times per second, creating a cosmic lighthouse effect. Imagine the power of a star compressed into such a tiny, dense object. For stars with a core mass greater than about 3 solar masses, no amount of pressure can prevent the collapse. The core continues to shrink, becoming so compact that it forms a singularity, an infinitely small point with immense density. This process creates a black hole, a region of space where gravity is so strong that not even light can escape. A black hole doesn't suck everything around it like in the movies, but its gravitational pull is so strong that anything that ventures too close gets pulled in, never to escape. Black holes are mysterious and elusive, but they play a crucial role in shaping galaxies, as most large galaxies have a supermassive black hole at their center. These objects are both fascinating and terrifying, and we can only begin to imagine the mysteries they hold in the depths of their gravity wells. White dwarfs. While the fate of massive stars is marked by dramatic explosions and mysterious remnants, the path of smaller stars, those with less than 8 times the mass of our Sun, is equally fascinating but less violent. Instead of blowing up in a supernova, these stars end their lives as white dwarfs. For stars like our Sun, the transformation into a white dwarf is a quieter, more gradual process, but no less important in the cosmic cycle. When a star like our Sun runs out of hydrogen fuel in its core, it begins to shed its outer layers, releasing a glowing shell of gas and dust known as a planetary nebula. What's left behind is the core of the star, which becomes the white dwarf. A white dwarf is a small, dense object about the size of Earth, but with a mass comparable to that of the Sun. This incredibly dense remnant is made primarily of carbon and oxygen, supported against further collapse by electron degeneracy pressure, a quantum mechanical force that arises from the Pauli exclusion principle. In simple terms, this pressure prevents the electrons in the white dwarf from being squished together. Over time, white dwarfs slowly cool and fade, becoming dimmer and dimmer over billions of years. Eventually, they will no longer emit any light or heat, leaving behind a cold, dark relic of the once glowing star. These white dwarfs are not completely lifeless, though. In fact, the elements they contain are some of the building blocks for new stars, planets, and even life. The cosmic recycling process continues as the white dwarf's remnants, its carbon and oxygen, might eventually become part of a future generation of stars or planets. Even in death, the star has a profound impact on the universe, passing on the elements needed for new life to take shape. Stars with lower mass end their lives not with a bang, but with a whisper, a slow, silent fade into the cosmic background. But even in their quieter demise, they play a vital role in the ongoing creation of the universe. The cosmic recycling. The death of a star, whether through a supernova explosion, the slow fading of a white dwarf, or the quiet collapse of a neutron star, is not the end of the story. In fact, it's only the beginning of a new chapter in the universe's vast and ongoing cycle of creation and destruction. The elements that were once forged in the heart of a star, hydrogen, helium, carbon, oxygen, iron, and more, are scattered throughout space, enriching the interstellar medium and becoming the building blocks for the next generation of stars, planets, and even life. When a massive star dies in a supernova, the explosion blasts these elements into space at incredibly high speeds, often faster than the speed of light. This cosmic spray of material can travel across vast distances, carrying with it the very elements that are essential for the formation of new stars and planets. For example, our own solar system was likely formed from the remnants of earlier supernovae. The heavy elements that make up the Earth, including the iron in our cores and the oxygen in our atmosphere, were born from the death of ancient stars. Without these stellar deaths, life as we know it would not exist. But it's not just supernovae that contribute to this cosmic recycling process. White dwarfs, the remnants of medium-sized stars, also play a role in this cosmic game of life and death. Over time, as white dwarfs slowly cool and fade, they might still release their residual elements into the surrounding space. These elements could be incorporated into new star-forming nebulae, further fueling the creation of new stars and planets. Moreover, neutron stars and black holes, while seemingly the ultimate end for a star, are not entirely disconnected from the cycle of stellar creation. For example, neutron stars can emit strong bursts of radiation known as gamma-ray bursts, one of the most powerful phenomena in the universe. These bursts of energy can trigger the formation of new stars in distant regions, essentially reigniting parts of the galaxy into new life. Even black holes, with their immense gravitational pull, can influence the formation of new stars by pulling in nearby gas and dust, providing the necessary material for star formation in a process known as accretion. Thus, the death of a star is not a solitary event, it is an essential part of a greater cosmic cycle. Each time a star dies, it releases the ingredients for new beginnings, new stars, new planets, and potentially even new life. The universe, it seems, is forever recycling itself, and each stellar death is a crucial step in this ongoing process of creation. The birth and death of stars are, in a sense, two sides of the same coin, forever linked in the vast, ever-changing tapestry of the cosmos. Thanks for joining me on this incredible journey through the life cycle of stars. From their dramatic births in swirling clouds of gas to their spectacular deaths that seed the universe with new elements, stars truly shape everything around us. The next time you look up at the night sky, you'll see more than just points of light. You'll see stories of creation, destruction, and cosmic rebirth. Stay curious, keep looking up, and keep wondering about the vast universe we call home. And if you love discovering the secret of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures. Did you know that La Niña events can reshape weather patterns across the entire globe, affecting millions of lives in ways you might never expect? From fierce storms to intense droughts, this natural climate phenomenon holds enormous power over our planet's future. Understanding La Niña isn't just about weather forecasts, it's about unlocking the secrets of Earth's climate engine. When La Niña strikes, the world doesn't just change, it transforms. What is La Niña and how does it form? Have you ever noticed how the weather sometimes seems to have a mind of its own? Unexpected storms, unusual droughts, or shifts in temperature that don't quite add up? That's often the Earth's way of reacting to a powerful climate pattern called La Niña. La Niña is essentially the cool sibling of El Niño, both part of a climate phenomenon known as the El Niño Southern Oscillation, or ENSO. It happens when the surface waters in the central and eastern Pacific Ocean become cooler than usual for several months. This cooling is caused by stronger than normal trade winds pushing warm surface water westward, allowing cold water from the deep ocean to rise up near the coast of South America. This shift in ocean temperature doesn't just stay put, it sends ripples through the atmosphere, changing weather patterns across the globe. La Niña events typically last from 9 months to 2 years and can repeat every 2 to 7 years. Because the oceans and atmosphere are so tightly connected, these changes in the Pacific can influence rainfall, temperature, and storm activity thousands of miles away. Understanding La Niña is like unlocking a key to predicting some of the most extreme weather events on Earth. Impact on global weather patterns. La Niña doesn't just mess with the weather locally, it rewires the planet's entire atmospheric system. When the Pacific Ocean cools down during La Niña, it shifts the jet streams. Those fast-moving air currents high in the atmosphere that steer storms and weather systems. This shift can cause some regions to experience colder, wetter winters, while others might face hotter, drier conditions. For example, during a La Niña event, the northern United States and Canada often get colder winters with more snow, while the southern United States tends to be warmer and drier. Across the globe, countries in Southeast Asia and Australia usually see heavier rainfall, sometimes leading to floods, while parts of South America, like Peru, often experience drought. These changes happen because La Niña alters the balance of heat and moisture in the atmosphere, changing how air moves around the planet. The result? A domino effect of weather changes that can disrupt agriculture, water supplies, and even energy demand. The global reach of La Niña is a reminder that what happens in one part of the world's oceans can have far-reaching consequences for millions of people everywhere. Effects on rainfall and droughts. When La Niña kicks in, it's like the planet's weather gets a major remix. Some places get drenched, while others barely see a drop of rain. This isn't random, it's all about how La Niña shifts moisture around the globe. In regions like Southeast Asia and Northern Australia, La Niña often brings heavy rains and flooding. These downpours can replenish water supplies and boost crops, but also cause serious damage when rivers overflow and landslides occur. Meanwhile, places like the southwestern United States and parts of South America often face the opposite drought. The lack of rain can stress farmers, dry up reservoirs, and increase wildfire risks. This push and pull of wet and dry conditions happens because La Niña changes wind patterns and ocean temperatures, which in turn influence where clouds form and where storms track. The result? Some communities might celebrate a season of abundant rain, while others brace for water shortages. Understanding these patterns helps governments and farmers prepare better, but the unpredictability still keeps everyone on their toes. Influence on hurricanes and tropical storms. La Niña doesn't just affect rain and drought, it also turbocharges hurricane activity, especially in the Atlantic Ocean. During La Niña years, the Atlantic tends to see more hurricanes and tropical storms, sometimes with greater intensity. Why? Because La Niña cools the surface waters of the eastern and central Pacific, which reduces wind shear over the Atlantic. Wind shear is like nature's way of breaking up storms before they get too strong. With less of it, hurricanes can grow bigger and last longer. This means coastal areas in the United States, the Caribbean, and parts of Central America face a higher risk of powerful storms. Meanwhile, the Pacific often experiences fewer hurricanes during La Niña, as the cooler waters and stronger winds suppress storm formation there. This seesaw effect between ocean basins shows just how interconnected Earth's climate system is. For communities in hurricane-prone areas, La Niña years are a time to be extra vigilant, prepare emergency plans, and stay informed because, honestly, the stakes are higher when the storms come knocking more often. Impact on agriculture and food security. When La Niña arrives, it's like the Earth's thermostat and watering system get out of sync, and farmers around the world feel the impact firsthand. Crops depend heavily on predictable weather. Too much rain can drown plants, while too little can starve them of water. La Niña's shifts in rainfall and temperature can cause both extremes depending on where you are. For example, in places like Australia and Southeast Asia, heavier rains can boost rice and sugarcane yields, but flooding can also ruin fields and delay planting. Meanwhile, drought-stricken areas like parts of South America and the southern United States might see their corn, soybean, and wheat harvests shrink. These disruptions ripple through the food supply chain, pushing prices up and threatening food security for vulnerable populations. Farmers must adapt quickly, sometimes changing planting schedules or switching crops. La Niña's unpredictable nature means that communities reliant on agriculture often face uncertainty, making it harder to plan for the future. The stakes are high because food isn't just about crops, it's about livelihoods, economies, and survival. Effects on marine life and fisheries. La Niña's chill in the Pacific Ocean doesn't just affect the weather, it sends shockwaves through marine ecosystems too. Cooler surface waters and stronger ocean currents during La Niña change, where nutrients rise from the deep, creating feeding hotspots for fish and other sea life. This can be great news for fisheries in some regions, boosting fish populations and catches. For example, the cold, nutrient-rich waters off the coast of South America often support thriving fisheries during La Niña years, but it's not all positive. The altered ocean conditions can disrupt breeding cycles and migration patterns for many marine species. Some fish may move to cooler waters, forcing fishermen to travel farther or adapt to different species. Coral reefs, sensitive to temperature changes, can also be stressed, affecting the entire marine food web. These shifts impact not only ecosystems, but also the millions of people worldwide who depend on fishing for food and income. La Niña reminds us that the ocean and atmosphere are deeply connected, and changes in one ripple through the other in surprising ways. Long-term climate and environmental consequences. La Niña isn't just a short-term weather event, it's a powerful player in the long game of Earth's climate. When La Niña events happen repeatedly over years or decades, they can leave lasting marks on ecosystems, weather patterns, and even human societies. These cycles influence drought frequency, wildfire risks, and the health of forests and wetlands. For example, extended La Niña periods can dry out some regions, making wildfires more likely and stressing plants and animals that rely on steady rainfall. Meanwhile, other areas might see repeated flooding that reshapes landscapes and disrupts communities. On a larger scale, La Niña interacts with global warming, sometimes masking or amplifying temperature trends. This makes predicting future climate conditions even more challenging. For people, these long-term shifts mean adapting how we manage water, agriculture, and disaster preparedness. Scientists study La Niña closely because understanding its patterns helps us prepare for a future where extreme weather might become the norm. It's a reminder that Earth's climate is a complex system, where ocean and atmosphere dance together, shaping life in ways we're still discovering. Thanks for joining us on Space Facts today. If you found this deep dive into La Niña fascinating, don't forget to hit that subscribe button and ring the bell icon so you never miss an update on the amazing forces shaping our planet and beyond. We'd love to hear your thoughts. Drop a comment below and tell us how La Niña has affected your area or what topic you want us to explore next. Stay curious, and we'll see you in the next video.